what we did is, right, so when you have Scab running on your machine, you do Scab version, right? It gives you access to Scabs, Cairo, and Sierra. So Sierra is safe intermediate representation, and Cairo version, this is what version is running on your machine. And this particular version will enable me to perform certain logic from my terminal if I want to compile my Cairo code using scap build. So we talked about some of the commands, right? Did I do that? I think I introduced that yesterday. So just a recap of what we did yesterday. So we introduced scap, and we said scap is what is the package manager. So that is what we did yesterday, and we have some we have scap build. So scap build helps you to what compile your Cairo program, compile Cairo program. So basically this, and then the next one is we'll talk about what scab Cairo run. So what this does is to what run a given Cairo program. So basically that, and this is what we did yesterday. So well, these are let's say common scab commands. And again, another important scap command that is important is scap format. Probably if we have, let's say we can scatter this code. Let's scatter it. It's so ugly, right? So scap FMT helps to format our code, format code appropriately, right? Appropriately, right? So this is what it does. So when I run scap FMT here, you can see it formats this code so well, and this is one of the things that we need to learn before we move on to the next level, right? So now today we'll be talking about StarkNet contract. So we introduced some of the data types. We talked about some of them. So let me go over them again. I think we talked about. So we said there are two types of data types. They can actually be categorized into two. We have the scalar data types and we have the what compound data types. And out of the scalar data types, these are the primitives. We talked about felts. We talked about integers. I think somebody's mic is on, so can you mute your mic? Thank you for joining us today again. So yeah, so if you have if you're coming from Cairo 0 background, it is the same felt 252. So basically felt 252 is the basic default data type of Cairo. So we talked about all these data types, talked about integers and booleans, and in our code, right, we started writing code to implement all of these default data types. We talked about felts. We talked about them yesterday, and we said that felt is the default data type, and if you don't specify the type of any variable, it is by default a felt. So we talked about that. We talked about how can use that to for short strings, and any character that is limited to 31 characters, you can actually use felt. If it's a string, you can actually use felt to hold that particular variable, right? So now we have say GM. So say GM is less than 31 characters. So that is why we are using felt to actually hold it here. So we talked about, so we use some of these functions. So to recap again, so this is how functions actually defined in Cairo. You write fn, which is the keyword for functions. The function name, you can actually pass in any function name here, right? So conventionally, if you want to have a function that does probably, like in this case, we're saying say name, we don't do camel casing, we do snake casing. So this is a snake casing convention. We say underscore, then name, then this bracket here, if we want to pass an argument into this particular function, then the return, this arrow function here means we're trying to return something. What we're returning in this case is a felt, and this is the body of the logic of say name, right? Within 22 and 23, we have a variable holding felt 252, right? And then we're returning it. So now this is implicit return, like I mentioned yesterday. We can actually have it explicitly returned. Explicit return will mean that we're using the return keyword. So and then we will have a semicolon. So make sure you end every line of code, right, with a semicolon. Otherwise, the compiler will not work, right? Unless in a case where you're trying to say implicitly return that particular value, like in this case here, we are implicitly returning result and we are not putting semicolon. If you put semicolon and try to compile this code, so it says car build. So yeah, car build. So we can see that it has a problem because it's expecting that we return a particular type, and it's seeing here that it's a unit. Unit is empty, right? So we need to specify, and you can see Cairo is very explicit enough. It is pointing us to the cause of the problem, so we have to put return here for this to work. So now, this is the basics of what we covered yesterday. We talked about typecasting, how we can actually convert from one particular data type to another. And what really brought us to that was the fact that we tried to compile a code that somebody has a question. Is there any question? All right. So basically, so that is what we did yesterday. We started this class on that note, and we'll be advancing to another level. So what really brought us to typecasting was when we talked about the max limit of every particular integer type. Integer is a scalar data type. That means a primitive data type for calculating, for performing arithmetic calculations. So in a case where we want to sum two numbers, we will make sure that we are not going out of the range of that particular type that we are specifying. Like in this case, we are saying this sum function here is taking two arguments, and the first argument is num1, which of type U8, and second argument is num2, which of type U8. We will not exceed 255 in all of these, right? So if we're going to say the first value should be 256 and this one should be 1, that will throw an error because we are going to go out of the range for the type U8. This type U8, the max value is 255, and that really brought us to typecasting. So we can actually go into the next integer type, which is U32, using this into keyword. So this allows us to scale the max value of U8 to U32 using into keyword. Like I mentioned yesterday, if you want to go from low to high, you use into, and when you want to go from high to low, like in this case, we want to do from 32 to U8, you can actually use try into, then you unwrap that particular value. Yeah, so that was what we did yesterday, and we wrapped up the class. We talked about StarkNet Foundry. So we'll be using StarkNet Foundry today in our class today. So right, so yeah, so for those of us who are joining us for the first time, so I will talk about StarkNet Foundry. So if I build this, let's build this and make sure everything is working well. Yeah, so it's working.
Hi, Dave.
Yeah,
Uh,
yeah, I'm listening.
sorry, sorry for interrupting, but I wanted to know firstly uh, why we have chosen Cairo language instead. Like we are also having some other languages like Rust and Solidity for smart contract programming, but why we have chosen this Cairo? I wanted to know this.
Come again, what did you say?
Why we have chosen Cairo language? Like what's the specific purpose it holds, like why only this language, for what specific purpose this language has been chosen.
All right, so yeah, so why StarkNet, right? So why Cairo? So Cairo enables
Yes.
us to write provable programs, right? So if you want to write any program that you're going to have a cryptographic proof for that particular program, you use Cairo. So everything you write must be proved. So if it is proved, that means the code you've written is kind of valid and it can be verified multiple times. So it is actually a particular language that was developed by Starkware, and it was used as a program to write dApps that will scale on StarkNet network, right? So we know the problems bedeviling Ethereum, and StarkNet developed their own solution, which abstracts away which abstract away bundling a lot of transactions off chain and sending a validity proof that will be verified on L1. So for you to write any program that will run on this layer 2 network, which is StarkNet, you must use Cairo, and that is what we are doing here, right? I hope that answers your question. If you were in the
Yes, yes.
introduction class, the introductory class by Darlington, I think he did justice to why Cairo and StarkNet is very important. So I don't know if that answers your question, right?
Yes, yes. Thanks.
All right, no problem. Sure. So today we'll be covering StarkNet contracts. So if you're here, you don't have I think let's start by writing some StarkNet contracts. So all the things we've written so far, they are stateless, meaning they don't have access to state. So we'll be writing a program that has access to state, and that is what we must be doing to build any solution that will be deployed on the network. Just like the way we have Solidity, right? For Ethereum, we have StarkNet contracts too, and then we have access to state. And if you can actually, if you want to write any logic that will live on the network, you can utilize Cairo to write StarkNet contracts. So now let's check. Let me do git add. Let me commit this and create another branch. Commit. Sure. Let's see. Feed intro to Cairo into primitive data types. So yeah, so we've done this. Let me check out that we StarkNet contract, right? So yeah, so we are going to be talking about StarkNet contract in today's session. So what I want to be doing today is I'll be creating let's say a simple counter contract. Let's call this counter. Okay, let's call it simple counter, right? Simple counter dot Cairo. So Cairo is the extension for writing StarkNet. Any bias. If you have .Cairo, that means that's a Cairo you're going to have Cairo implemented, right? So just the way we have .js, we have .Cairo extension, and that's how it depicts that this file is actually a Cairo program. Yes. So how do we write Cairo contract, a StarkNet contract, which has access to state? Now, for us to do this, we must use the StarkNet. We must use StarkNet, and then we'll say interface. So here we'll define our trait. So basically, before we start, you need a trait. I need what? An implementation, right? So we're writing all of this right now. So let's go. So we'll have a simple counter contract, and we'll say what? Trait let's call it I counter. Then it has access to what? T, let's call it T contract state. Okay, this works. So yeah. So let me just move this, call this, let's say I counter, yeah. So we have access to certain functions. We can actually say set count, right? And we can say what? Self. Should I write it from scratch so that it's kind of understandable so that everybody understands what I'm trying to do? So now, so this is the name of the trait we're trying to create. Remember, for you to write any StarkNet contract, we need a trait and then an implementation. So the trait is kind of like the blueprint, right? Let's say it's the blueprint for the blueprint that captures the functions we want to write. So in this case, we're going to have what? Fn what? Let's say Fn set count. And in this Fn set count, we can have ref self. Don't worry, we'll talk about this. We have access to what? T contrast state, and then we're not returning anything. So now, Fn what? Get count. So we're going to have access to self, and we'll be, let's say, have access to what? The snapshot of contract state. So basically what we're trying to do is, let's say, don't worry guys, I will explain. So what is happening here really, right? So like I mentioned, this is how to write StarkNet contracts. You must have a trait and an implementation block, right? So we want to create an interface. Interfaces are ways to write the function signature that we want to implement, right? So this function signature are kind of like the blueprint of a particular function, like what do we want to do? Now we are being introduced to certain things here, and those things are kind of weird to us. And one of them is generic. This generic here means we'll be having this kind of a placeholder to the storage of our contract, and this is how it works. We'll be passing in this storage to our contract that we're going to implement. So we're going to have we're going to say let's call it I simple counter, and this is how to do that. Right. So before we start anything, let me just implement. Let me just remove this. Let me remove this. So I will say mod what? Mod simple counter. Right. So it knows about this simple count. So let me try to like build this. So it's build. Yeah. So we will start writing our StarkNet contract. So for this to work, we should have what? StarkNet. So we say StarkNet. Are we following, guys? Hello? Are we here?
Yes, we are.
Yes.
All right. Please let me know if you're lost. So now, what am I trying to do? I'm trying to create a simple counter contract, and I will explain what is happening under the hood, right? So we don't need events for now. Let's remove event. Let's just comment this out, right? So basically, we can say this is what simple counter. This contract is called simple counter. Let's call it I simple. So we understand what's happening. I simple counter. Now we have this contract. This is how to write a smart contract on StarkNet, right? So this contract will have access to states that remember states. You want to have a state where you can perform what? Read, write operations on. Read, write, read. Let's say public cloud operations. We are all developers. We know create, read, update, and delete, right? So these are basically the functions we want to perform on this particular contract, right? In our state, right? So we have, so when we define this mod means a module, right? We call it any custom name we want to call it. You can call it anything. We can say guild audit, for instance, and then we open these curly braces. Automatically, the compiler will treat this particular logic as a contract. Now, we want to implement these traits that we have defined up here. So, but we need something, right? We need to specify the particular storage. So storage actually defined using the storage attribute. So these are attributes, right? So this is an attribute, this is an attribute, and this is an attribute. So for you to know that this is a contract, you have to specify this StarkNet contract attribute. And then for you to know that this is an interface, right, you must specify this attribute, and this attribute with this sign, right? I hope that makes sense. Now, this storage is what we're trying to manipulate. We're trying to like update this particular storage. We can say what? We can have count, and we can say it's type what? U32. So remember, we talked about the primitive data types, and we have a lot of integer data types. We have U8, U16 like that, and we also have U32. So struct is another data type that is kind of a compound data type. So it now allows us to have customs, right? So it's customizable. What does that mean? So we can have a collection of different data types, right? So we can have count of U8. We can have name of what, of type, let's say of type, or let's say it can be felt 252, right? Like, right. So this particular struct, right, allows us to have dynamic data types. So for now, we're actually keeping this contract very simple, right? So just follow me, guys. So now we're going to have an implementation block, right? So we're going to have an NPL, so allowing this to auto complete for me. So what is happening here is we specify this attribute ABI embed v0. It allows us to have ABI generated for these particular functions we're trying to implement in this particular block, right? The implementation block is where we give life to this trait we have defined here. Does that make sense? So we're going to set count and read count, basically what we're doing. Yeah, so let's go. So a shortcut to do this, just copy what we have here and bring it down here. Let's say I simple counter NPL of what? Of I simple counter. Don't worry, we'll talk about it. Will not compile. We'll have some issues and we'll solve those issues, right? So let's open this up and talk about what we're trying to do.
Dave, I just wanted to know, like
Yeah.
you are simply implementing the functions of the interface,
Yes,
I simple counter. Yes.
yes.
So, why have you written ABI in the attribute?
Oh yeah, so this attribute allows us to have this as a public function so that once we compile and deploy our contract, we can have this, just we know how we use ABI in Solidity, right? So we can actually have
Yes, yes.
this particular, we have an ABI generated for this function signatures we have in this implementation block.
But in Solidity, when we compile the Solidity contract, we get the ABI.
Yes. So yeah,
So
so
why we have written ABI? Still, we haven't completed our contract and we haven't
this
compiled
means,
it yet.
so yeah, so we can actually take a look at so let's go to Cairo book. So we can say ABI v0, ABI v0. INPL. Let's see that. So so like I mentioned, right? Eventually, when you have this attribute for a particular implementation block, it enables you to actually, for visibility, right? It also means that, most importantly, that this particular what's it called, this particular implementations, this logic actually implements what's it called, the trait we have defined up here. And also
Okay,
when,
got it.
yeah, sure. So we're going to set count. So we're going to say, so what self does is to give us access to this storage struct we have here. So we have it as the first argument. So every contract must have structs, must have this struct storage, right? And you have access to this struct storage using this ref self. So ref self means modify the state of the variable of the storage, right? And what storage are we talking about here? We're talking about what contract state. Let me remove this. So note something happening here. So in here, we are saying this is a placeholder. This could be anything. We could say T. Let's say put it like this and put T, for instance. And then this means give me anything that is passed into this particular, give me access to the storage that is passed into this particular I counter trait, and that is how it works. And we're trying to implement that here. We're saying this contrast state is this storage that we have in this particular struct, right? So we're trying to manipulate this storage struct, and this is depicted by what? Self. Self means storage. That is what we're passing into this particular. We're passing this into this I simple counter trait that we have up here. But so it will not work. So let me see something. SRC. So let's make sure everything works well. Yeah. So it will not work because some things are happening. Have you seen? Always compile your code to make sure everything works well. So let me make this clear. So I think I could like kill this, and so yeah. So why is it not working? Something is happening, right? So let me run it again. Start build. It should not work because some things are missing, right? So yeah, so simple counter should be so let's have this like this. So yeah, SCAR build, unsupported attribute, StarkNet contract, storage, unsupported attribute, okay, API v0. All right, so let's try to use the keywords called super. So we're going to set self dot count dot write. We're going to write to say, okay, I think before we do this, let's say let current count equals to what? Let's say it's of type u32 equals to what? Self dot count dot read. So have this. So we want to let's say we want to do we want to, okay, let's just write to it. Let's just have another argument here that says let's say amount is of u32. Amount should be here of u32. Just in amount here. So this should write to state for us. So basically that. So what is happening here? We are saying this is a function that is going to implement what we have here, right? This blueprint set count, and we're going to say passing an amount here and let this amount override everything we have here. So by default, when you deploy this contract, count is going to be 0. So when you pass in an amount into this function, probably let's say 10, automatically this count will be set to 10, just the way we have in Solidity, right? Now we want to read from state. We can say what? Self dot count dot read. So basically that, and yeah. So this is implicit return. So let's have explicit return. We can say self dot count dot read. Let's see let count equals to this, and we want to return this. So we want to return count. So yeah, so let's try to run this and see if it works. Can build. Oh yeah, so okay, contrast state, what's happening? Yeah, I don't know why that's not working, but this should work normally. Is it the latest unsupported attribute storage? Am I using the latest contrast state? Yeah. So let's replicate this GM StarkNet. All right, let's see. So let me create this simple counter. Let me say counter Cairo. Use this here and trying to import counter here and see. Let's see mod counter. So yeah. So let's go. So yeah, so this works. If you can see my screen, but I think actually used SM Foundry to spin this up. So we have the simple counter. So let me basically delete all this. So this is our simple counter contract, and basically what it does is to take a particular value as argument into set count, and what we are doing basically is to modify the state of count. So this right means passing this value, and then this will be the value of this count of our storage, right? So the state per time will change when we all set count, passing one amount, and we can actually take this a step further and then say start. We will assert that amount not equals 0. So that means nobody can pass in 0 here. Invalid amount. So let's just do this like this. So basically this. So when we run this cap build, so if it compiles, so this implementation block, this is our blueprint. Yeah. So basically these, I don't know why it was not working then, but now I think, yeah. So this is how we can write a simple count contract. Who does not understand what we've done so far?
Dave, will you please explain when we have to use ref and when we have to use self?
Okay,
Like
yeah. So let me.
what are their data types or what?
All right. So sorry for the mix up there. So basically, what happens is when we use ref is when we have to modify state. So in the case where we're going to modify state, so this means ref means we want to manipulate the state of this particular contract count, right? This count here, we want to modify this. We want to anytime you have ref means okay, let me have it somewhere here. So let's put it somewhere here. Let's see ref modify state. So when we have this snapshot, we're having self and this snapshot. This means what? This means take a snapshot. That means read only. And basically that. So we're trying to read from the state of the contract, which is what is we're doing using this particular art symbol here. So basically this means give us the state of this contract, the state of count as is, and then return it. So that's what we're doing. Remember, we are saying return this particular count, give it to us, because we're saying give us of type 2U32. That's what we're doing. We'll read the state and we'll return it. So we can also have, I gave two methods of doing this. We can say we can have this implicit and explicit return, right? And implicit return will mean this. So when we do this, automatically we're implicitly returning, we're saying self.count.read, so it returns this particular value when we call get count. So that is what we're doing, right? If that answers your question.
Yes, got it.
All right, no problem. So this is what we're doing. So we're going to be doing a lot of stuff. We're going to be modifying this. We're going to be writing tests. If time permits sorts, I want to make sure everybody's following what I'm doing here. So now we have our counter contract. We have done this. Let's say we're going to create a version 2. So we're going to have a version 2 of this counter contract, right? So we're going to have version V2 of Cairo. Yeah. So let's have this particular V2. So what this V2 does, we will have, so this V2 is going to be I counter what? Let's say I counter V2. So we have V2. Let me use this. So every have place we have the instance of, we have V2. So what is going to happen is, yes, we're going to have an amount, set count and get count. We're going to increase and then we're going to decrease. So what we're going to do here is something unique. So we're going to have another thing. We're going to have another storage variable, and we're going to have what? Owner. And owner is going to be of what? Contract address. So yes, so we're going to be introducing contract address, right? So contract address is another type for StarkNet contract. So this is how we do msg.sender in Solidity, right? So we want only owner to be the person that will deploy. Once an owner is set, that owner can only set count. So that brings us to something we're going to be talking about. We're going to be talking about what? Constructor. So this is how to write constructor in Cairo. So this is auto-completing tool for me. So when I do, it completes it for me. So we have the FN keyword to describe that this particular function is it's a function, and the name of the function, in this case, constructors. Constructor is a reserved word. It's a keyword that is used in StarkNet contract to depict that the logic you're going to enclose within this block is going to be deployed once, right? Just the way you have it in Solidity. So once you deploy this contract, anything you said in this logic will be set. It only runs once, and that is how it works, right? Now we're going to be doing something here. We'll be doing what? We'll be setting an owner. I'll be saying of type what? Contract address. So what we're going to do here is we're going to say self. Remember, we're trying to mutate the state of owner, right? And that's why we have ref self. Ref self is giving us access to modify this owner, right? To modify the storage. In this case, the owner variable we've set here. So we'll say self dot what? Owner dot what? Right. So what we're going to pass in is this owner, and basically that. So remember, this is not Solidity. In Solidity, you can say msg.sender equals to what? Owner. So in Solidity, you have something like this. We have a particular method we're going to be importing, right? We'll be importing it here. We can say use StarkNet. So StarkNet has a lot of methods, right? So we will use this, and we can get let's say get caller address. So this caller address is how we do msg.sender in Solidity. So note, never you say let caller equals to what? Get caller address, and you do something like this, just like the way you have in Solidity, and you said you can actually say the msg.sender is like the msg.sender of a constructor of a contract should automatically be the owner. In Cairo, that does not work. We'll be introducing universal, what we call, let's say, you call it what? UDC, right? Universal deployer contract, right? So you cannot do this. You cannot say self.owner.right. We cannot say this equals to what? Caller. This is wrong because the address of this caller using this this get caller address method, right, is the address of the what? The UDC contract. And this automatically means that this contract, you've lost access to this contract, right? Because you don't have access to the account of the UDC, right? So this is not a safe way to deploy any contract.
Dave, what is this UDC contract, and why we can't store this caller in the self.honor.write function?
Okay, now, so UDC is universal deployer contract. So when you actually going to deploy any contract, there is a universal public good, right? I think currently we have Open Zeppelin. They have the UDC. You can actually check it out. Let's check it out. Let's see, Open Zeppelin, UDC. Yeah. So this Open Zeppelin UDC contract is there's a low level function called what the deploy syscall. So we don't have to call this deploy syscall. Under the hood, SM4G is doing all the heavy lifting for us. So we just it calls this for us, but the account calling this is the account of the UDC. So there's a warning. I can actually share this resource, and let me share it in the call so that we understand what is happening, right? So anytime we're going to deploy any contract, because this is a security class, so as developers writing contracts that will be deployed on the StarkNet network, we should abide by the best possible standards, security-wise, right? So security should be our watchword. So when deploying a contract that uses the get caller address in the constructor, right? Remember the UDC and not the account, not you. So in the case where we have something like this, where is that contract? So yeah, so in the case we have something like this, so let me even close this, right? Okay, let's just call this like this. So in the case where we have something like this, if you do something like this, right, according to this documentation here, it's warning you that this automatically gives you access to the UDC address, right? So when you want to write that address as the owner, that means you've lost access to this contract. That means you cannot perform certain operations like what we're trying to implement. We want to implement that only owner can call this set count function in this version 2, right? So just follow me, guys. We'll write some tests if time permits us. So this is what I want us to do in this version 2. And also note some important key security features while deploying a contract in this constructor, right? Within the constructor logic, never you do this like you do in Solidity. Always passing the address, in this case, an owner, and make sure that this address is passed in as constructor, then can actually do this. So this is wrong, right? So never do this like you'd have in Solidity, because this is a vulnerable. Okay, let me put it as what? Vulnerable code. So this is vulnerable. Vulnerable. Yeah. So this is the correct way of implementing this logic, right? You pass in this owner here, and that owner becomes the owner of this contractor, of this contract, sorry, this counter V2 counter contract, right? So yeah, so please note this. Now we want to do something different from what we did in the version 1. So in the version 1, we just anybody could like set count. We don't want that. We want in version 2 that only owner must be the person that can set this particular contract, right? That can set count. So we can say let caller, so we can come here, copy this. Okay, let me just hard code this so that all of us can see what's happening. Let caller equals to what? Contract address. Let's say get caller address. And so what we're saying is assert. So assert is like required statement in Solidity. So we're going to say that assert that what? Caller equals what? Self dot owner dot what? Dot read. And then we have an error message here, caller not owner. So this ensures that only owner can call this contract. Then we are certain that the amount passed in is what? Not 0. And then we can actually write self.count.write. So let's always, anytime you write any new logic, make sure you run this cap build to make sure that your code is currently working. So it's working. So if you have this finish release target in how many seconds, that means your code is currently compiling. So yeah, so this is it. So if you have any questions, let's go more advanced and introduce certain concepts. If you have any question, please feel free to ask the question, right? Any questions so far? Hi. Hello, everyone. Do we have questions?
Mm-mm.
No, not yet.
Does this make sense so far?
Yes, it does.
Okay, no problem. Awesome. So now what we're going to be doing is we're going to create another version of this contract, right? We're going to be implementing certain things. So basically, we said this contract, with this particular class, will be testing. We're doing some testing, right? Um, we'll be testing, right? So set count. So we have another one called what, version 3, and we're going to test all these things we're writing now. So we're going to have what, counter version v3 and say .cairo. Let's just copy everything we have in v2 and copy it into what, v3 with a few modifications, right? So we learned about the UDC and how to set it in the constructor. Now we will have some things we're going to have. We're going to have an addition logic. We can say addition.cairo. So this addition will be the first thing we're going to be doing for testing, right? So so we'll have a function, we'll have a public function. So before we function, we can say add num or let's call it sum numbers, and we're going to have what, let's say x, let's say u32, y u32, and it's going to what, return what, u32. Basically this. So what we're going to be having here is what, we're going to be returning implicitly x plus y, and that is what we're going to do in this function. So we're going to have this mod, let's say mod what, mod addition. So this is how to import, right? So use the keyword called mod. Every file within the source folder of your contract. So when you create your package, you have the source folder, you have your test, you have. So I'm using SM Foundry. So sorry guys, make sure you have SM Foundry working. So when you do SN Forge dash version, we'll see the version we're using. So I mentioned SM Foundry yesterday. I talked about that. I mentioned that I said for us to proceed in this class, we must have I think I talked about it. I said we must have SM Foundry installed. I don't know where that is. Okay, I think git checkout. Let me change this dash. Git checkout main. Yeah, so main, I think we talked about this, right? So in our last class, we talked about using StarkNet Foundry. So StarkNet Foundry gives us two modules, like I mentioned yesterday. We'll be using StarkNet Foundry. Now I started using it already. So make sure you have StarkNet Foundry installed. Let's try to like go to their documentation. StarkNet Foundry, first steps. So for you to start using this, you must have Scarp installed, and installation. Yeah, you must have Scarp installed, and visit this page. Let me put it in the call so that we'll have access to this resource for installing SM Foundry. So basically, what we're going to be doing, like after I write this particular contract, we're going to be testing, right? We'll be doing introduction to testing. I don't know if this is too much information, but I've been given the task of introducing StarkNet contract testing in this particular section. I'll try to cover that. So yeah, so make sure you have StarkNet Foundry installed, and it gives us access to SM Forge and SM Cast. So SM Forge is the module, the binary that's responsible for initializing a project and for testing, while SM Cast is for making interactions to StarkNet, right? So probably you want to declare a contract, or you want to deploy an account, you want to create and deploy an account on the network, or you want to invoke the methods of your contract, or you want to call the functions methods of your contract. So use SNCast. So basically that we'll be seeing how we'll be using all these shortly. So let's go. I think we've covered that. We've talked about this. Yeah, sure. So yeah, so let's see how we can start testing this logic we've added here. So what is even bringing us here? Everything within this source file, this SRC file, are modules, right? They are modules, right? So the compiler treats them as modules. So we want to import this particular addition. We want to import addition to we'll be using this addition in this v3, right? The version v3 is going to be kind of it's going to have more features than v2, and we'll be doing that now. We'll be seeing how we'll be importing our file. We'll be using let's say use. So now we want to use this addition, right? This addition, right? We want to use it. We want to use it in this version 3 of our contract. So first of all, before we even start, let's modify all instances of v2 to v3, and then this should be what v3. Let's convert it what v3. Yeah, and then also bring it to our oh yeah, I don't have, okay, let's say mount counter. Oh wow, let me bring what we have here. Let's bring counter v2 here. Yeah, I think v2 is there's some errors. Yeah, so we need to import certain things. So we're going to, let's see, shouting. We don't, it doesn't, okay, type not found. Let's explicitly specify that. So if you want to import more than one stuff, so get caller address, contract address. So yeah, if you want to, so this is how to import more than one. So you want to have access to multiple imports, right? So inside this StarkNet, we want to import get caller address. I want to import contract address, right? So these types, we want to have them. I want to have access to this contract address type. I want to have access to this method get caller address. So we use, so once you, so this is not good, it is not readable. So for those of us coming to write StarkNet for the first time, so get caller address. If you write caller address, let's say, and then this is something like this, can say this StarkNet contract address. So this is not really cool, right? So why not have a one-liner? One-liner in this case, have, instead of you to be writing multiple, if instead of you writing get use StarkNet, I remember one of the principles of coding is what? Keep it dry, do not repeat yourself. Don't try to repeat yourself. So don't use StarkNet get caller address like that. So this is just a one-liner. So we'll not be using this. So we just use this guy and it should work. So yeah, so this was access to contract address type and everything should work, right? So let me do scarp build. Always scarp build every time, right? To make sure everything is working well. So this works. So let me import my v3 and make sure everything works. I think inside here we can have access to what mod counter v3. So it's yelling at us. Some things are not working. So we're going to just do this. Yeah. So we're going to say get caller address. We're going to have contract address. So basically this should work. So now let's start to writing the logic we want to implement here. And so now we have access to storage, and then let's remove this. We always really know that this is an implementation block and that. So now, so let's remove this. We know this already. Always do scarp fmt to format your code so it looks clean. Now, so what we're going to do here is we're going to, let's remove this guy too. So we're going to do something else. So we're going to use this addition logic here. How do we use it, right? So we will have addition. We'll bring addition to our core lib.cairo. This is the entry point. So we're going to say addition. We'll have access to addition, this logic here, right? So we're going to have access. We want to call this sum num inside inside the V3 contract. So what are we doing? So we will import that using use, let's say, inside this set count. So once we will not be adding this amount like that, we want to what? Increase count. Let's say, let's call this, instead of increase count, we'll say yeah, increase count. Let's call it, let's do this. Instead of setting count, yeah, let's have, in addition to set count, let's have another one called what? Increase count. So we're going to say increase count, and we're going to have always, instead of rewriting, just, this is a short way of doing, copying our trace to implementation. Just copy this, come here and do this. So this should work. Just change this because we need that to what? Contrast state, and that is it, basically. Right. So what we're going to be doing here, my code is not clean, so I'll do my scap format. So yeah, format my code now. So what I want to do here is what I want to. So everything basically we've done here. I think we're going to copy it. I will copy this guy and making sure that the owner is the one calling. But in addition to, yeah, so in addition to this, we can say let some result equals to what? Let's say what's that? Use yeah. Let's say use addition. Yeah. So now, so how do we import this particular guy? So I think some things are here that I've not really explained, right? So we have, let me collapse this, right? So everything outside this particular simple counter module, this particular simple counter V3 contract is not visible outside this block. So from line 9, everything outside here is not visible to this particular from 10 to 50. So to have everything outside this module, right? This module accessible within this module, this simple counter contract, we use the keyword called what? Super. That is what we're using here. We're saying, give us access to this this simple counter V3 interface, right? So this is how to use it, right? Now we want to import this addition. How do we do this? We can do this by saying, remember, this module is called what? GM. This is the name of our project, right? We say what? Use, comment, hold on, GM underscore what? Addition, and that is it. Let's say we want to have access to what? Some norm. So this is how we've imported this function here. We've imported this function some norm using this keyword some norm. So now some of us will be wondering, what is pub? Pub means public. Let this particular function be visible globally, right? So regardless of where you're trying to use it, you can actually use it. If you remove this keyword pub, the compiler will not compile. So what we're going to be doing is what? Some norm. We can see we have access to this some norm because when we hover over this, it is telling us that what? Expected 2 and found 0, wrong number of arguments. So we're going to pass in what? Let current count equals to what? U32, and this is what? self.count.read. And this is basically what we're trying to do here. We're going to get this current count, right? We get current count plus what? Plus amount. So this is, let's sum result. We're summing these two numbers. And what do we want to do with this sum result? We want to say self.count.write. So we're going to say sum result. So this is how we want to sum whatever value, right, that is the current state of this contract. Probably before now it is 0. we want to pass in this amount to that 0, and it should give us, probably we want to put in 5 plus 0, we should increase this contract by that new amount, and that is increase count, right? So let's try to compile this. Always format your code so that's clean. I do this a lot, so always what? Let's build. So let's do start build. This compiles our code. If this works, that means everything's working well. Now, any questions so far? Any questions so far, guys? Any question? Any questions so far?
No question from this end.
All right, so fine. So we're good. So let's start introduction to what testing. So let's do some testings. So first of all, we'll be testing. Or should we take a break? It's been like 1 hour. I don't know if we can take a short break. If you guys are okay with that. I guess okay with short breaks. I can't see. I don't want to. So if you're okay with short breaks, we can actually go. Okay, or we should just continue. I just want to make sure everything is working fine. Somebody wants to ask a question. Oh yeah, Juliet.
Okay, good evening, sir. So the addition.cairo file there, I don't know what's the content of.
Okay, look at it. So now, good question. Remember, I mentioned something. I said we will be testing, right? So every logic of your contract, you must test it to make sure it's working. So if you're adding 2 values, make sure that it is working accordingly. So that in a case that you have 10 plus 10, it should return 20, not 20, 25 or 200. So testing is very important. That is why I want us to introduce us to what unit testing and integration testing. So we'll see how we're going to write tests against this particular logic to see how it works. So we want to utilize this particular function in our contract. So now there are 2 things while writing Cairo. There's Cairo program, which is a stateless logic, and there's a StarkNet contract, right? Cairo programs can be used within your contract, right? So this is a stateless logic, right? It's just a simple arithmetic calculation logic, right? So we want to utilize this particular logic in our contract in this V3, and that's what I want us to do. Does that answer your question?
Yes.
All right, no problem. Thanks. So any questions? Any other questions? So let's start testing. So before you start testing, I mentioned earlier that we have 2 modules, right? We said StarkNet Foundry gives us access to what? SMForge and SMCast. So we'll be utilizing SMForge for testing. So make sure you have SMForge installed on your machine. So I have SMForge, so I'll be writing tests. So the first test, okay, let me show, so just a quick rundown of testing. So why testing and how it's necessary, right? So testing, we must test so that, so this is one of the, I gave a talk in the last StarkNet Lagos conference, and this covers that. It's all about testing. So we must test to make sure that we must to guarantee the intended functionality deployed to the network, right? So we must validate that the functionality behaves as intended, right? And also to prevent costly errors during development. Small errors can lead to significant losses. So fair, it is not a secure approach to rely on post-deployment fixes. So even before you deploy, right, try to run the test and make sure it's working as appropriate as possible before you deploy to the networks. Not such that you'll not be depending on post-deployment fixes. Not messing after that. Let it be tested thoroughly. Make sure that everything is working as intended before you actually deploy your logic to the network, right? Remember, anything you deploy in the network is like very open. Everybody can see it. If there's a loophole, and some persons can, malicious entities, malicious bad actors can take advantage and exploit that vulnerability, right? So your 2 plus 2 logic must always return 4. Write tests that your 2 plus 2 addition logic returns 4. And every attempt to return 5 or 3, anything outside 4 fails, right? We will see how we're doing that in the next session. Just to give a recap. So yeah, so these are the benefits. I will share this slide, so let me not talk too much. So rect.news is home to all crypto hacks, right? All hacks. So many protocols have been hacked. You don't want your the product you're building to be hacked. So always write rigorous tests. Now, so this is just an overview of that. So we don't waste time talking about the theoretical aspect, right? So let's write some tests for this code. So there are a lot of tests. We have unit testing, which is what I'm going to be doing. Unit testing is separating each logic, right? And testing that they work the way they should work, right? So we'll have this. So to test, so we'll use this keyword called what? CFG. So CFG is means a configuration, and we're passing in what? Test into it. So it's expecting what? A module called what? Tests. And this is where all tests we'll be writing will be. Are we together? So let's do some stuff here. So remember, this is what U32. The max value of U32. Somebody should do the max. 2 raised to power 32. Can somebody do the math for us? Even while you're doing that, let me not rely on that. The max value of U32 is this value. So we have 429496725. So this is the max value of U32. So everything outside this value will fail. So let's write a test that anything we're trying to add that is not within this range, right, should fail. So in tests, the most important thing in tests is assertions. Our assertions should be the key thing that we should rely on to make sure that everything we're testing work the way they should work. All right. So now let's go. So so every attempt to what? So let's have a should panic. So I don't know, this is auto-completing for me. I don't want the auto-complete, right? Let's say should panic. So what this means is this particular logic in this test. Let's have this test. So before you start writing tests, have this particular attribute test. So this particular logic here should perform the test. So we have a function called what? Test some norm should panic. So it should overflow, should panic. So what we're saying is, hey, this function should what? Panic. So let's try to remember I mentioned super, right? Instead of using super multiple times, okay, let's just use super. Let's use super. Super means we're referring to this particular function here. Let's say super sum norm. So let's copy the mass value, right? And let's say +1. So this should work when we run SN Forge. So let's do SN Forge test. So yes, it's passing. Why? Because the max value of U32. Remember, we started this journey yesterday when we said to get the max value of any particular integer data type, we can say 2 raised to power n minus 1. N in this case, the integer type. If it is U8, you say 2 raised to power 8 minus 1, starting from 0. So the max value of U8 is what? The max value of U8 is what? So somebody should do the mathematics and get that for us. So for U32, the max value is what? This. So anything exceeding this should what? Panic to make sure that this works. So this is how we write our test, right? So let's put 4. So this will not work. Let's see why it will not work. Because it's not panic. Have you seen? Guys, can you see my screen? Hello?
Yes, we can see your screen, sir.
Basically, what we're saying is the max value is this value for U32. And when we add this plus 1, it is within the range of the carrying capacity of U32. So this should not panic. And that is why we have fail. It is yelling at us that this particular function here of our test, which is what? Failing. We expected it to what? Panic, but it didn't, right? And it's saying what? 0 passed, 1 failed, 0 skipped, and 0 ignored. And that is basically what is happening. So when we go back and say 5.
Oh, Rust. That's so Rust. No, it's trash.
It's a what? Hello? Somebody saying something?
Please proceed. I'm just joking with someone here.
All right, sure. All right, nice. So yeah, so this means this is passing, and you can see, right, because the max value of U32 is what? This value 429, and this is it. So if we add plus 1, it should panic. We should make sure that it what? This is the panic overflow error that is throwing to us, and we are capturing it using this should panic attribute. So this is for all negative cases, right? So let's test for positive case, right? So this, what we're going to do here is what? Test, and then we're going to say fn test sum norm. So this is in a positive case. So when we say super and sum norm, so we can say like what 10. So let's have this saved in the variable. Let's say let result equals to what? 10 plus 10. Let's say 10 plus 5, and let's assert that we can have an assert statement here saying that result equals what? Equals what? 10 invalid some norm fail, some norm, can say some norm, let's say some norm logic, invalid some norm logic, let's say. And while using this, you must make sure that you are not exceeding 31 character. So let's run this and see. So when we run SM forge test, let's see. It's failing, yes, as expected. We'll put it to 15. So this should work. Let's see. Yeah. So result 10 plus 5 is equals to 15. We can also have this another way, written another way, using this assert macro and saying result equals to 15. So we don't have to add this what's happening? Assert, I'm coming, just hold on. Okay, yeah, assert equals, sorry, don't mind me, guys. Sorry, assert equals, right? EQ. So yeah, result equals to what? 15. So yeah. So that's that. Let's just run this. So this should work. So this or this, 19 or 18, can be used interchangeably, right? So 19 means instead of you to write it without this the third argument here, which is a string literal that should throw if this does not work, you can actually use this so this means deep equality. This should be this, and basically that. So we are done with unit testing of our sum norm logic. So let's go over to, are we together, guys? Hey guys, are we together?
Yes.
All right. So yeah. So basically,
Yeah, I have a question.
yeah.
They
Sure. Your
said
question.
each test function must you always start it with test?
I didn't hear you.
The test function, the name, must they always start with test?
Yes. So for best practices, right? So if you check the documentation, this is how to the standard, right? You can say test the name of the function like that. So test some num should panic. That means this is a negative case using this should panic attribute. So this should work. So that is how.
Okay, so it's a best practice, not
Yes.
really.
Yeah. Best
So if I
practice.
use something else, it will still work.
Anything you use, it will work. Anything. Let's
Okay.
even try it. Let's say some num um, um, let's run the same test. Yeah, it worked. Now there are some things. Now this one is working, but I don't want you to run with this one. Remember, it's saying two tests. It's running two tests, but I want to ignore this one. You can actually use this ignore and use this ignore, and we just when we run test, it will ignore the other one and just run this particular sum norm. So yeah, you can see one ignored, one passed, 0 failed, 0 skipped, and 1 ignored. So if you're coming from Foundry or Solidity, you will see that these are kind of similar, right? So for best practice, always have this prefix test, the name of that. So now we have ensured that this particular function here, this addition add some logic works. How did we even get here? Make sure you have StarkNet Foundry installed on your machine, so that when you run SN Foundry up, so you should have access to what it should give you SN Forge and SN Cast. Don't worry, we've seen how we'll be using SN Cast after testing to deploy our contracts, right? So basically so we've tested this code and it's working. So let's go to this guy here. This guy, so what we did is a unit test. So when we write test within this particular file, we're enclosing it here and it's a unit test. So you can actually have this test outside, but since this is not doing much, it's just this particular logic, you can actually have it within here, right? So this is what we've done. So let's go to this counter contract and write test for this counter contract, right? Are we together, guys?
Yes,
Tired?
sir.
Are we tired?
No.
I am not.
All right, no problem. So we will be doing integration test. An integration test is housed outside the contract, and this is how you write it, right? We would have been saying test what? Let me okay. I mean, okay, let's leave this one. Let's say test counter. Let's test counter dot Cairo. This is the version 1. And what we're going to be doing, right? The first thing that we'll be doing, right? Let's try to is everybody following? I want to make sure everybody's following. Please, guys, if you're not following, please draw my attention. We could like go over what is not clear and make sure we're all on the same page. Now, so now are we following, guys?
Yes, sir.
So now we will so to utilize this particular everything we have in our contract outside the contract, we must import them, right? And one of the things we will be importing, we'll be importing a lot of things from StarkNet. StarkNet is giving us access to a lot of things, so we'll be using StarkNet to import certain methods, right? So we'll be using StarkNet to import contract address, right? Because this contract address will be important. If you go to our code in this, let's go there. This is our counter guy. We've not started. Okay, yeah, we will use it because when we're going to be declaring our contract and deploying, we'll see how that works, right? So let's have this. The next thing we're going to be using here is remember in your scap.toml file, right? We have this guy called what? smforge. Sorry, smforge standard library. We have access to this guy. Are we together, guys? Hello.
Go on, sir.
So
You can
this
hear.
SM4 standard library, we are pointing to this GitHub repo and we are using this tag. This means give us access to this every method in this particular repo. And that is how we're going to be using what. So let's even go there. Let's even see what we are importing so that it is not confusing, right? So we will be SM Foundry. Yeah. So let's go to, so like I mentioned earlier, we have SM Cast and SM Forge. This is what we're interested in, right? This particular SM Forge standard library. And that is what we imported in our code, right? So this is what we have access to. So we have a lot of things here. We'll be seeing them. We have access to cheat codes. Don't worry too much, guys. We'll see how all these things work when we start testing. So this is what we're interested in. And we have access to it by importing it in here. We'll be importing this. We'll be saying SM4 standard library. We'll be importing a lot of things, right? One of the things that is important, we'll see how this works. Well, remember, I didn't mention this, but unlike Solidity, once you have, it's a two-step process. Let me break it down, right? So you have a contract. Let's say this is our counter contract, right? Let's say our counter contract here. Let's say counter contract here. So it is a two-step process of deployment, right? Let me put it two-step process for deployment. So now the first one is what? We have to declare this contract. And I mentioned it earlier in the last class yesterday to deploy. So declaration gives us class hash, but don't worry too much about this because under the hood, this has handled it for us for this test environment. But when we're going to be deploying in real life using SNCast, when we declare, we'll get a class hash, we'll use that class hash to deploy. But don't worry, guys, too much. This is for testing. For test purposes, we'll see how this works. So we need this declare method, right? We need this declare. I will need contract class trait. So we'll talk about this, like, right? So now before we start doing anything, the most important thing, right, for us to do, we need a utility function, right? We call it what? Deploy contract. You can call it anything you want. Deploy logic. Let's call it deploy logic, right? Or let's call it deploy contract. So it's kind of easy to relate with. So this is going to return what? A contract address that we'll be using, right? So let's start. So we said it's a two-step process. So we're going to copy this. I use this a lot when I'm going writing my code. So when I do FMT, yeah. So declare. Let's declare. We're going to say let what? Let our contract instance equals to what? Declare. And what are we declaring? We can call it anything. Okay, let's say our contract name is what? Let's go to our counter contract. Our counter contract is what? Simple counter, and let's put it here. And we must unwrap because unwrap gives us access to, in case anything happens, let's handle it properly. So this gives us access to the declared instance, right? And we need to deploy this particular contract, and that is what we're going to be doing here. So now, remember, this is a utility function we've just written. So let me format this to be clean. So deploy. So the deploy will mean we will use now something very important, an important concept we'll be learning here. We'll be saying contract what deploy, call deploy method, and what we're going to be doing here is we'll generate a new array trait. Somebody has a question?
Yes, I do.
Yeah,
So
sure.
online, why are you unwrapping?
So yeah, in case it throws an error, like we'll handle it well. In case anything happens, in case it's not successful, right? Unwrap means handle this particular stuff for us, right? Handle every associated error, right? In case anything happens, so handle it efficiently. If it fails, handle it well. So that is what we're trying to do. Remember, this is not a kind of It means like if you're coming from a backend development background, when you make an external API call to a server, it's either successful or it fails. So in the event it's successful, handle it. In the event it fails, handle it. So that is what unwrap is doing. So when we declare, remember this is a method we are calling, right? Passing in the name of the contract. We want to, is it simple counter we call it? Yeah. Simple counter, right? So yeah, so for V1 is simple counter. So yeah, so this enables us to do that. Does that make sense? Hello?
Yes, it does. Thank you very much.
Oh, no problem. Yeah. So this returns multiple stuff. The first argument, it returns a tuple, and the first argument is the contract address, which is what we're interested in, the contract address. The second one, we're not interested in it because at this point, we can actually see all these methods when we go to here, but for time's sake, let's leave that and just probably I can give that as an assignment, right? All right. So now we will return what? We'll return contract address. So this is how we return implicitly contract address. So let's do scab fmt to make sure everything is clean. Now we'll start writing code, right? I don't know if anybody have any question at this point. Does anybody have any question?
Okay, the declare method we are calling,
Yeah.
it automatically finds the simple counter contract. Yeah,
So everything within this particular source file, it will be looking out for any module called simple counter.
Okay,
So
understood.
it finds it, all the modules. Remember, we imported all these modules in our lib.cairo, remember. So we take a look at, if we take a look at across all these files and check which one is called simple counter. Don't worry, we'll see how it works when we
I
start.
understand.
So yeah, so that's what's happening. So now we've written our TTT function. The next thing we're going to be doing is what? We're going to be checking whether this thing is working. Let's say our FN, let's say test increase balance. So yeah, so this is what we're going to be doing. And it must be denoted with what? The test attribute, right? So we denote the logic with test attribute. And so now we need an instance of our contract address. So we're going to say let contract address. I don't know if we're all together.
Yes, sir.
Now, something will not work. I want it not to work so that we'll understand how we can utilize the appropriate. We'll see the power of traits now. So now, remember, we need to call this utility function, right? Deploy contract, and this returns an address for us, right? That's what we're interested in. Now, what will happen? We need to pass in this an address to an instance of like an interface. Remember, in Solidity, if you're coming from Solidity, once you pass in an address to an interface, you are having access to the contract instance, and you can call the methods of that contract in Solidity. The same thing applies in Cairo. Now we have this trait, right? We specified in this trait, in this counter contract. This trait is going to give us access to things that will enable us to access this simple counter function, this simple counter contract, to access the functions set count and get count. Now, to do this, we need access to what? Remember, we need access to the name of the module. The name of this module is what? Sorry, the name of this project is what? GM. So this is it. So we say GM. I want to access what? What do we want to access? Can somebody help us? I want to know if we're all truly following.
Trait interface.
Yeah, we want to get all the interfaces, right? So we will have access to what? Let's say counter. Let's say counter dot what? Like there's a lot of interfaces there. So we're going to have access to what? Let's copy that. Where is that counter contract? Let's copy that I simple counter. Yeah, we're going to say this I simple. Let's say dispatcher. Then this dispatcher treat. Dispatcher treat. Now we're going to have access to what? Let dispatcher equals to what? I simple counter dispatcher, then we'll pass in this contract address. So this gives us an instance of this contract here. So we can call these methods in it, right? So it gives us access to this particular contract, and we can call set count and get count. So now basically this, so we can say what? We can safely increase the balance, so increase the count and see if it works. So now, before we check, always assert, always have an assertion, right? Let's even get the count before. Let's say count 1, which is the count before we increase. It's equals to what? Dispatcher dot what? Get count. I hope this, and yeah. So once we do this, we can assert that what? Every time before we change the state, it's always what? 0. Yeah, it should be 0, right? Invalid count. So let's run this and see. Let's say test increase balance, not increase count. Sorry, increase count. Oh wow, not increase count. What? Okay. Oh no. Is what am I doing? Is set count, test set count. Oh wow. Is the version 1, right? Set count, right? Please guys, are we together? Let's do SN forge test and so let's see if this works. Oh wow. Oh yeah. Equals yeah. So yeah. So it's my bad. So it's working. It's not visible. Yes, it's not visible in this context. Let's see. I counter. Oh wow, GM counter. It's not visible. Yes, for us to make it visible in here, we will have to add the keyword what? Pub. So let's run it again and see. This should work. Wow, it's not visible in this context. I counter. Okay, let's put pub here. Let's see if this works. All right. It should work. Yeah, anytime it compiles, yeah, it's working. Now, I think it's not from here. Sorry for that mix up. It's not from here. It's just from the trait I earlier specified. If it compiles, oh wow. Okay, I must specify it as yeah. So I think this is the new implementation, anyways. So this pop keywords means expose this particular counter outside SRC so that anywhere inside this test folder we can actually access it. So that is what that keyword is doing for us. So now, so first things first, sorry guys, I think I forgot to mention this, right? So let's even remove everything here. Anytime you want to write a test, right? Let's remove this. Let's cut it out, right? Write an assert 1. Okay, let's say assert. Let's say assert. Can I say assert 1 equals 1 invalid amount. So let's test always before you even test to make sure that your test is working, right? If it works, that means it's working. So you can actually do you can do SM forge test. So specify the name of this particular test. SM forge test, then test set count. So this is how to isolate a particular test and run it only, and it should work. If it works, that means everything is working well. So it's giving you the feedback on your terminal that tests, you can see it is testing that test counter and this particular test set count is working well. So this is how to make sure this is like the hello world in your test. So I forgot to mention that. So guys, please note that. So let's remove this and run this again. Let's go through this again. So let's do this. So the count before we increase the count, which is count 1, is what? 0, and the assertion is working. So this is what is making our test to work as this assert, right? Yeah. So this is assertion keyword to make sure that what before you increase balance, it is what? 0, and if it fails, that means your test is not valid. So now the next thing we're going to do is what? Try to increase balance. So let's try to increase balance. So it's very simple. When we have this instance setting set up by saying iSimple counter. So what is this thing? Where do we get access to this thing, to these dispatchers that we got, right? It is gotten from, please remember our trait. Every time we specify a trait in the contract, right? There are a lot of dispatchers, right? So we have the dispatcher trait and the dispatcher. Dispatcher is what we're using. We'll see how we use the dispatcher traits. So all of them are very useful. So without this dispatcher trait, this dispatcher will not work. Let's try to remove this guy here and see if this code will work. It will not work. It will shout at us, right? So if we undo that, we'll see that we will have access to the traits that this dispatcher gives us. So who has a question? Please ask your question.
The dispatcher and dispatcher traits, they are implicitly generated, right?
Yeah. Thank you for that question. By default, the compiler, every time you declare a particular trait, it generates the dispatcher, the corresponding dispatcher for that particular trait. So this dispatcher is what we're going to be using outside this particular contract to interact with this contract. So because this trait specifies the function signatures that I want to implement, right, in this implementation block, we can get this dispatcher, the corresponding dispatcher of iSimple counter, passing the address, which is what we are doing here, to have an instance of simple counter contract and call the methods within that simple counter contract. Does that make sense? Hello?
It does make sense, huh?
Yeah, sure, no problem. Thanks. So basically that. And remember, you must have this utility function for deployment, right? So this is a utility function called, let's call it utility deployment function, right? So this is a utility deployment function that you must have if you want to test and StarkNet contracts. Now we have a dispatcher called what? Let's call the method increase. We want to what? Set count. We want to set count. We want to pass in what? 10. Right? Let's call this comment. Hold on. Let's say let amount, which is of U32 equals to what? 10. And we will pass in what? This amount here. And then what we're going to do is what? We'll have this assertion statement here. We'll assert this. We'll assert that what? Let's call it let count 2. Let's just say let count 2 equals to what? Dispatcher dot get count. So we're reading it again. I want to see this thing. So get count should be what? 10. Invalid count. So this should work. So let's test and see. So it is working. So if we pass in 15 here, let's say for instance, because 0 plus, so we've overwritten 0 with what? 10, which is the new value we set our count state variable to become, right? So let's say we want to test if it is 15. So this should fail. it will fail. It's 10 because it is 10 that it's expecting. So have you seen it? Invalid count, right? And then that is how it works, right? If it failed, right? And it's showing this error, invalid count. So we have a way to check this. So we assert that this is this, and we can assert that what? There's a negative not equal this thing, this macro. Not equal means assert that this count 2 is not what? 15. We don't need this unnecessary argument, and this is how it works. So if we run this should pass. We are certain that 10 is not 15, and it is true. That means, and so this is a valid test, and everything is working as intended. Now, in our code, remember, we mentioned something. We said that every line of code within our contract must be tested, and that is what we're trying to do here. In this our contract, we are setting the variables, right? And it is passing. Now, in this contract in line 23, he's saying something, saying that we should assert that 0 should not be passed in as a value for amount. So now we're going to test it. This is a positive case. Also test negative cases, right? So instead of writing from scratch, let me just, because of time, because we have very limited time, and I'll give an assignment, right? So now we're going to do what? We're going to do something. We're going to do something here. So we've all these things are working up to this point. Let's comment out this guy, and we should do SM forge test cannot set count. So please, this thing should be descriptive enough. The name of your function of your test should be descriptive enough. So test cannot set count with 0 amount. So what this means is any attempt to set 0, which is the validation logic we're having here, right? It should what? Fail. Does that make sense? So we want to test that this line 23 assertion logic is working. So how do we do that? Remember the should panic keyword we used here, right? We use it again. This should panic. We just come here, copy it, and put it here. So what should panic? So an attempt to what? So let's put this with what? Let's remove this guy. I think this should this is clear enough. This should what? 0. So this should panic. So let's run the test. So let's do test what? Copy this particular. So yeah. So do this. So this should pass, because yes, everything invalid amount, which is what we're having here. Where is our count? Where's our counter contract? So we're putting invalid amount. Let's say 0 not allowed. 0 not allowed. I hope this, make sure that this does not exceed 31 characters, otherwise it will throw an error. So it should yell panic with this 0 not allowed. Have you seen 0 not allowed, which is what we are passing here now? So now, but this is not working well, because we don't want it to be doing the way it's behaving. We want it to panic with the appropriate this thing. So now what should we do in this case? Anybody have any idea? Hello? Who has an idea? Hello, guys.
Yeah, I can hear you.
Yeah, who has an idea of how we're going to do this?
I don't understand what you're trying to do.
All right, no problem. So expected that let's 0 not allowed. So yeah. So let's change this and put it like this and try to see what happens. Hello, are we together? So
Yes.
test the explicit error message of the validation logic of this counter contract in line 23. I think our time is fast spent. I think I'll be giving assignment after this, or probably we can continue tomorrow, right? So now, to assert that this particular zero not allowed error message is really captured in our test, I'm introducing something new here. I'm saying, in addition to this should panic, we want to assess the explicit error message of this particular line 23 of our counter contract. We don't want zero amount, and we want it could panic with anything, but we want it to panic with the appropriate error message we have specified. In this case, zero not allowed, zero not allowed, right? We want it to give us this same particular error message, and that's what we're using inside this should panic, right? We are saying expected, passing this as a single string, right? And it is giving us what we want. Remember, in the contract, it's what zero not allowed, but I mistakenly removed this e, and you can see it here. It's saying zero not allowed, expected, and this is like this is the actual value of the error message that we are spitting out in line 23. But what we put in here is what we omitted the e, and it is yelling that it has what failed because this is incorrect panic data. So when I put that back, this test will to pass. So this is another way to appropriately capture panic data. Like in the contract, we have in line 23 that hey, why will you put zero in this? Want to pass in zero? Don't pass in zero. So we don't want zero. So we want to capture that this line works, and that is how we do it in line 36 of our test, right? So that is basically what we can do. We run this test again, and everything should pass. Yeah, so it's passing. So so this works. So let me even write some comments. Contract get contract address of our of contracts, right? Then initialize contract instance. Then the next thing, call count, right? Then our assertion here. Then this is attempt to increase to set count with zero value. Attempt to set count with zero amount, and this is it. So basically, how the test is broken down, right? So guys, I think this works. I think if I want to run all the tests. So I think I don't want anything to be ignored. So I think I have ignore here. So I'll remove this and run smforge test. If I do smforge test, so everything should work. So if you see all the 4 tests across this across multiple files in this particular project, they are all working. Now we're going to write tests for V2. We're going to write tests for V3, but because of time, this class is fast spent. We spent like 2 hours trying to like make sure everything is working well. So tomorrow, I think let's try to like schedule the class. I think I will align with David, the guild audit team, so that we can actually find a time to complete the remaining versions of this counter contract. We'll probably have a version 4 where we can actually transfer ownership, right? And also test it and deploy all these contracts, right? We're going to be creating an account. We're going to be deploying the accounts to the network, and that's basically what we'll be doing. I think I'm so happy and excited for all of us that's joined this call, and I hope we learned one or two lessons in this very short class. It's short for me, but come on, we spent 2 hours anyways, but it's fine. Let's see if we have questions. Does anyone have any questions so far?
Is there a repo for this?
Yes, I'll
workshop?
push this code. I'll push it right away. And I'll provide the link to this code in the Discord server so that all of us can have access to the code and the assignments too. So I'm giving an assignment, right? So I'll push this code now. So you guys should write. I've done everything from version 1, which is the counter. So we're going to have version 2. Write test for version 2, right? And version 3, trying to do version 3 too. And I'll give for version 4. Version 4 will mean we are going to have another function here for transferring ownership, like transfer ownership function, right? And get owner, right? So we're going to have that, and we're going to test it to make sure it's working. Don't worry, guys. We're going to get a hang of all these things in the next session, right? Any other questions?
The expected keyword is mostly used when there are multiple assert statements in a function, and you want to
Yes.
specify.
Yes, in a contract, right? So yes. So it's kind of very helpful, right? Like you want to know why it's even panicking, right? So the explicit panic data, you want to get it, like the error message. In this case, we're saying encounter version 1, amount not 0. Like this particular, I want to get this. I want to make sure that it's panicking with this particular error message. Yeah.
Understood.
Yeah, no problem. Thank you very much, guys. I hope we had fun. We're going to continue the next class. We're going to deploy. We're going to add some stuff, deploy. So everybody an assignment. So make sure you do version 2. Version 2, passing a constructor. I think this is easy. We've not started any hacking here. So just try to write tests for version 2 and see how you understand the concept we've covered this evening. Thank you very much, everyone. I hope we've been able to cover a whole lot. I see you guys. I will see you guys tomorrow, right? No problem. Thanks, Temitope. Thanks, Juliet, for your time. Have a wonderful evening.
So,
Oh yeah, Juliet, you have a question. You have a question.
Yeah, I do. So you said we're going to have like you are going to ask David if we can have like an extra class. Is that going to be tomorrow or?
Yeah, so I think I will communicate with Dave and the Guild team so that we can schedule that class and announce in the Discord server so that everybody's aware of the class, so that we can just briefly cover the test for other ones, go through the assignments, and try to deploy all these contracts.
Okay.
No problem. Hope you had fun.
Sure.
yeah, it was.
Thanks, guys. No problem. Have a wonderful evening, guys. Bye.
Thank you.